Well, I got this little one all the way done now. I've been using it to cut molds and RC car parts and stuff like that. That was cut on it. That one, I got some others that were cut on it. So what I've done to it, this was a 3040. And I added a 1-inch steel base plus a Saunders machine point 9 of an inch. So it's almost an inch thick base, Saunders jaws, 3/8 inch thick plates added to each side of the Z, 3/4 inch thick plate added to the back to step it back so that I could fine tune my X-axis rails. I do use it sideways to the room because it has to fit in an area that's small, but I get used to that. It has mist, it has flood. I had changed the block and all of that. So that's done. I 3D printed myself a catch box that I put a filter in. It catches a lot of the chips for me that's coming out. I had this one made. I didn't have a way to do it, but it's the bottom box is an aluminum box. It's 10 inches high, little side, and for the doors that open and close, these are ball bearing drawer slides with 1/4 inch glass. And then the case is just made out of 1.5 by 1.5 extrusion. I use a Grizzly pump system at the bottom, runs into a filter, comes up, and that's for my flood. I just use one of these chillers that runs my antifreeze mixture that runs up through the orange tube to the 2.2 kW, basically 3 horsepower motor. Then I have my mist here. As you see, I got 2 flood nozzles. I also just made had the one that came with it, but I hated it, so I took a piece of 1/4 inch plexi and fused it to this piece of aluminum, so it's exactly 14 millimeters thick. So that's my tool setting one. And then I have this probe I also put in line, and I don't have it wired in yet. I need to get an extension so I can wire it in, and then a little box to put the end in on the inside to keep it clean so it doesn't get anything in the USB plug. But anyhow, on that, this one I touch off my X and Y so I know exactly where the material is. And then the other option that I did was, let's see, I added automated. At first I just put in push buttons. These are now disconnected, but I left the power connected to the lights so they light up so they don't just sit there dumb, but they're not connected. So the mist and the flood is now controlled in this box that it comes with. If you do these, you recognize this box. And the board that's in it, they say doesn't control the different things. Well, it does if you set it up on the board and you turn everything on inside of your Fusion 360. So, and I moved my homing switches. I moved the one switch that was in the back all the way to the front. So it homes over to this corner because it was homing back there to that corner. So I moved the switch from that side to this side and from that side to this side. So now everything goes to the corner that I want in the room that it's in where the drains are. So it's got a drain in the front, a drain in the back. They come down and drop into this box that I 3D printed, which has that green has got a lot of holes in it. And it ports into this box, which has a screen catch inside of it also to help catch any chips. And then it catches the chips in this filter that gets back so you don't recut chips in your coolant. And then I just dump all my chips. As that gets about halfway full, 3/4 full, I take that out and dump them into that bucket. So what did I end up doing? It did not do this at first, but now I can turn the spindle on. You can hear it come up. Let's see if I can do this. And I turned it back off with Mach 3. So let's go over in Mach 3 to the diagnostics page so I can turn everything off and on. Spindle. You hear it, spindle run. Spindle off. I'll go to my flood so I can put in an M8 command for the flood. And the flood is now on. Now the flood's back off. That was on the flood right there. And as you can see, there's nothing coming out of the mister. It takes a second for it to actually mist, but you'll be able to hear it. That was the mist kicked on. You can see it a little bit. There it starts. Mist back off. So now I have my mist and my flood comes on automatic and turns off. My spindle turns on automatic and off, and it sets the RPM that I need to turn that particular bit at. I literally have everything on this except for an automatic tool changer. On the 3040s, when I added this base, you notice it sticks out a little bit further. So that gave me about another 2 inches of travel in the y-axis. So that helped out it. So it's actually bigger than a 3040, but it's smaller than a 6040. So it helped me out a little bit. And then this plate is faced off. It's actually recessed down a little bit, but as you see, that was faced off, and that's as shiny as could be. I can run this tolerance crazy tight for this machine, and that was able to do it because I had 2.5 inch by 3 inch steel bars are under here, and then this rail zigzag bolts down to it inside the linear rails. So that bolts into those plates. Those are underneath the bottom. They're about, well, they're 3.5 inches wide by 2.5 inches tall. It runs from full end to end. Like I said, I've got an inch solid steel plate here, plus this is a 1/10 from being a full inch thick here. So it's definitely rigid through the base. The only thing I want to do, I want to add another gusset to it that runs all the way up to here from down here. So I will be adding another gusset. But like I said, I just want to show this can be done. The MPG works perfect on it. I can go through and do everything that I need. It stops, shuts the coolant off. And what I had to do down here on this tank here, this button here is just bypassed, so this just always just stays like that. But everything runs exactly as you would expect it, and that's just an extra plate. So I have a couple 3D printed parts. I got 2 of these printed. One has a filter in it, like I said, down here. That's from Grizzly. That's their 7-gallon cooling pump system. That's from Amazon. I don't remember how much it was. You do have to change the fittings on it, which are a pain in the tail to find them. And then you can run your cooling off of that. It never gets above 35. It's like 35.6 is as high as I've ever seen it in centigrade. So whatever that is, I'm probably going to change this out to Fahrenheit so it makes sense to me, because that doesn't. Measurements, millimeter and inch, I'm okay with, but temperatures, it just doesn't. No. But anyhow, that's what I set up. The other things that were set all the way up was the offsets. I did change the screen some, And then, so I got plus and Y, internal and external circle, and all of that will read off of this sensor. Which that one I still got to figure out how to get the wiring in there so that it doesn't get chips in it. Because as you can see, it does throw aluminum chips off. I mean, I got aluminum chips on the ceiling, so I don't want any chips getting into that USB. And then the only thing I can do now was if I could come up with a way to use a miniature style TTS type system or something. I don't know if anybody makes such a creature, but if that was made, then I could put a tool changer in here and preset all my tool heights, and that would be extra nice. I will be doing that with this one over here. That Grizzly has been completely converted to full CNC also, upgraded. All the bracing material is coming in this week. But anyhow, this one, it's cutting really nice, especially now that it has the flood that turns itself off and on, or the mist that turns itself off and on. So when it's finishing a cut, I can literally go and do something else, and when it's done, everything is just shut off. But it's been a learning curve. I definitely appreciate all the online videos that I had, and the people that have helped walk me through. Even though some of the stuff was on the Grizzly machine, it's still correlated to the settings inside of this one on this gantry-based machine. So, I mean, once you figure out how to do it in one machine, you can do it pretty much, I say, in all machines. But the trick that really helped this out was changing this base, adding the steel pieces underneath here, and giving it another 3/4 inch thick steel plate that went all the way across the back. That's, I think, 9 inches tall. So it's 9 inch by 3/4 by 26 or 24, something like that. I don't remember how wide it was. And then that bolted through into there with the long bolts, and I used an all thread bolt to run it in with the special tool that grabs the outside. Then I added these nuts to it, and then I put these on it so I could put the stock cover back on it. So it literally added that much space. This line used to be even with this spot right here, but once I put all that extra material back here, it pushed it back that far. So my next thing I might do is, when I add this gusset here, I'll probably cut new arms here for the gantry top, and I'll let this one come back probably about another 2.5 inches, step back this way, and that'll give me a lot more Y-axis. Because right now you've got from here, from that line there to here, is just dead space. And I have room to bring it back. As you can see, I can bring it back about 3 inches before it hits the wall. Then I'll have to relocate this piece, which I can put it in that back corner over there, and it would never hit it in that back corner either. It's just convenient to take it down right here. But anyhow, this started out life as a steel-based machine, 3040 China-based machine that got a massive overhaul. To reiterate it now has mist, it has flood, it auto turns off the spindle. I can see the RPM. I can load a G-code. It does everything. Starts it, stops it, starts a flood, stops the flood. It functions as a good machine now. So if you have any questions or anything, want to know how I did or where I got some stuff from, send me a message. I'll point you to the directions of where I got my information from the best I can remember. And if I just had the answer, it was most likely because I learned it from somebody else, and now I've used it so much, I mean, I just know it. So once you learn it and know it, you kind of know it. But I always give credit to the guys that helped me learn this along the journey of taking one of these machines and making it do something that it technically really wasn't intended to do, which is cut molds that are that shiny a finish on this machine. But to do it, you're going to spend some money and some time and materials to beef these things up in order to get it to do it. Everybody have a good day, and I hope this can be useful to somebody to get the inspiration to know that it can be done, it can be wired. You will have to put some relays in your control box. You will have to do wiring. You will have to go into Mach 3 and turn settings on those boards. But the boards, they actually will do a lot more than what they pre-program these for. And it's just because they don't put the programming on them, and the programming is really hard to find online about doing it. Like I said, any questions on this, feel free to ask me. I'll tell you how I did it. And it seems to be working for me. Now I just got to get my feeds and speeds even better. At this point, that's my limitation, is the feeds and speeds. And on this one, once I make this go back further, I will put an automatic tool changer on it, which will have 6 tools across the back here, so it could drop all the way back and change the tool. There's a company that makes the tool changer kit for it, the 6040, and you can put them on these. It's just not common because you have such little amount of space if you have this thick of a Z-axis portion on your machine and the larger motor. So you lose, what, 5 inches of movement right there. But I'll fix that with this piece down here and this piece right here. That'll be my next upgrades. Everybody have a good day, and be inspired at all times by little things you run across.